The quantum shimmer. Is the universe a giant wave? Recent scientific advancements suggest that fuzzy dark matter, composed of ultralight bosons, is replacing traditional particle theories as the primary structural force of the universe. This discovery shifts the scientific understanding of cosmic architecture from a collection of isolated matter to a coherent, informational field. To understand fuzzy dark matter, it is necessary to examine the model it replaces. Cold dark matter. Traditionally, dark matter was thought to consist of WIMPs, weakly interacting massive particles. These are heavy particles that clump together like grains of sand. Cold dark matter theories predict that the centers of galaxies should be pointy or cuspy, meaning they are densest at the absolute center. Observations, however, show galactic centers that are far less dense than cold dark matter predicts. Fuzzy dark matter consists of ultralight bosons with an extremely low mass. Because these particles are so light, they behave like a liquid or mist rather than solid particles. The defining characteristic of fuzzy dark matter is its de Broglie wavelength. While quantum behavior is typically associated with the subatomic level, the wavelength of fuzzy dark matter particles is roughly 3,000 light-years long. Instead of clumping like sand, this dark matter acts as a quantum wave. It interferes with itself, creating fringes, ripples, and fuzziness. In this model, the dark matter holding a galaxy together functions as a non-local ocean. If the vacuum is a portal to another dimension, fuzzy dark matter represents the informational ocean that fills that dimension, occasionally interacting with our 3D world. Scientists have entered a make or break phase to verify fuzzy dark matter through specific observational signatures. Fuzzy dark matter predicts a soliton, a smooth bubbling core of quantum waves, at the center of galaxies rather than a sharp peak. Researchers are using the James Webb Space Telescope to observe high redshift dwarf galaxies. Here is why they are so important to our conversation about fuzzy dark matter and the vacuum. Those little red dots are the superstars of the high redshift dwarf galaxy world. Astronomers use the little red dot nickname because in the first JWST images, that's exactly what they looked like. Tiny ruby-coloured pinpricks. Their formal scientific name is usually compact red sources. If these galaxies show smooth cores rather than sharp peaks, it would provide significant evidence for fuzzy dark matter. These ruby-coloured pinpricks are high redshift dwarf galaxies that appear too mature for their age. They have as many stars as the Milky Way, but are 100 times smaller and contain supermassive black holes that grew at unexpected speeds. When scientists look at the light from a little red dot, they see a unique V-shape in the spectrum. The blue side is sharp, fast-moving hydrogen gas orbiting the black hole at millions of miles per hour. The red side is a deep, dusty glow that hides the rest of the galaxy. The wave-like pressure of a Soliton Core allows stars and black holes to form almost instantly, providing a structural anchor for these compact galaxies. When light from a distant quasar passes through dark matter, The dark matter acts as a gravitational lens. If dark matter is composed of particles, the lens appears smooth. If it is fuzzy, the lens will shimmer due to internal interference patterns within the quantum waves. Researchers are currently using advanced lensing studies to detect this flicker. Because fuzzy dark matter is a wave, it causes a slight oscillation or rhythmic jitter in a galaxy's gravitational field. Scientists monitor pulsars, highly accurate cosmic clocks, for timing irregularities. Recent data from arrays like Nanograv has detected a background hum. This is considered the first potential direct recording of ultralight waves vibrating through space. Verification of these signatures would confirm that quantum mechanics governs large-scale cosmic architecture. This would support the following post-materialist scientific postulates. The entire scaffolding of the universe is a single coherent quantum wave function. On a galactic scale, the universe behaves like a Bose-Einstein condensate, a state of matter where every part is synchronized and functions as a single unit. This confirms the existence of a single, coherent informational field that permeates space, suggesting galaxies function as macro-quantum systems. Fuzzy dark matter provides the medium, or ether, for non-local entanglement, allowing information to travel across the bulk. This aligns with the model of universal consciousness and a universal operator based on astrophysics. The era of verification. Astrophysics is likely 1 to 3 years away from a definitive announcement. Confirmation of fuzzy dark matter would end the materialist view of the universe as a collection of separate chunks of matter. It would be replaced by a scientific model of a universe composed of interfering waves of information, in which the Soliton Core functions as the informational brain of a galaxy. The cosmos, in this view, operates as a single, interconnected wave function.